Okay, back at it with 3.6, part 2, shifting and reflecting. So this is over the weekend, so 1 and A should get this done before Monday, 9/8, and 2 should get this done before Tuesday, 9/29. Where did September go also? Like, what? 9/29 already? So this is 3.6 part 2, shifting, reflecting graphs of functions, and our objectives are vertical and horizontal shifts and reflecting graphs. Homework, problem set 3.6, part 2, posted on Math Lab, and video will be linked, and guided notes will be posted. Everything on that assignment guide, so you can just click away, knock out all your math work. So, part 1, vertical and horizontal shifting. We can transform the graphs of functions by simply shifting and reflecting the graphs of common functions. So as a fun little review right now, you are going to go ahead and complete the tables with ordered pairs for each given function and draw a rough sketch of each. So common function 1, y equals x. So basically what I want you to do right now is pause the video and then go ahead and graph these basic functions. And they should be familiar to you. For example, y equals x. So I gave you some x values for this, and then we know that y is equal to x. So like -3, -3, 0, 0, 1. Well, I'm not going to do the whole thing for you. I want you to fill out the table and then draw a little coordinate plane, probably nicer than that one. That one looked pretty bad, and graph the points from the table and get a rough idea of what these 4 common functions look like. Again, they should be familiar to you. This is stuff that you've definitely gone over before in Algebra 1. So common function 1, y equals x, that's a line. Common function 2, y equals x squared, a parabola. But again, I want you to fill out these tables and graph the whole thing. It's a good review. Common function 3, y equals the square root of x. Reminder, the domain is x greater than or equal to 0. So this function starts, if we're looking at an axis, right here and goes like that. There's nothing on this side because you can't take the square root of a negative number until later this year when we learn about something called I. But I digress. Common function 3, y equals square root of x, and common function 4, y equals the absolute value of x. So I want you to have nice little graphs drawn for each of these common functions because it's really important you know what they look like so that you can do some transformations of them. So go ahead and do that, pause the video, and then check your graphs using your graphing calculator or this nice graphing calculator that I linked, Desmos. So that being said, let's go right into the meat of this lesson, which is vertical shifts, which starts with vertical shifts, upward and downward. So if we let k be a positive number, then the graph of g of x equals f of x plus k is the same as f of x, but moved k units upward. Okay, and then the graph of g of x is the graph of f of x minus k, which is the same as f of x, moved k units downward. And if this is like, wait, what? Right now, I think that after we do an example, you will start to see, and after you do the homework problems, again, this is just like a framework, and then once you do the homework problems, the idea is that you kind of are able to draw those connections and like, you know, have those nice little light bulb moments where everything makes sense. And if not, I'm so happy to help you get there. So anyway, without plotting points, sketch the graph of each pair of functions on the same set of axes. So f of x equals x squared and g of x equals x squared plus 2. So I'm going to start by drawing my very best set of axes. So it's going to be like 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so first thing, f of x equals x squared. So we just did that right above, so we know that there's going to be a point at 0, 0, there's going to be a point at 1, 1, there's going to be a point at 2, 4, and then that's mirrored over here. So I know that the graph of y equals x squared, immediately, that took me like 2 seconds to graph. So that's why we do those, you know, that initial exercise is that I want you to be able to draw those 4 basic functions right off the top of your head. So I see y equals x squared, bam, I know exactly what it looks like, where some key points are. But now we want to think about g of x is equal to x squared plus 2. So this is exactly in the form of graph of g of x equals f of x plus k. So we have g of x equals f of x plus k, where our f of x is equal to x squared and our k is equal to 2. So that means that if we follow our graph of f of x plus k is the same as f of x, move k units upward. Well, okay, we know that, oops, didn't mean to do that. We know that our graph is x squared, and we know that our k is 2. And so let me rearrange that, and let me go ahead and try to erase those arrows that I drew. Go away. Okay, cool. So now we know our graph is going to be the graph of y equals x squared moved 2 units upward. So 2 units, oh my gosh, why? No. Come back, axis. Pen. So 2 units upward, and then we have the graph of y equals x squared. So I didn't really draw a good axis, or I didn't really draw this like well for myself. I should have drawn some better points there. But again, it's going to be this exact graph. It's going to be the exact same as the yellow one, but it's drawn 2 units upward. I should actually fix that a little bit because that's a pretty bad graph. So, okay, I can look at my yellow graph and be like, okay, so if I start at the origin, I go up 1 over 1. So up 1 over 1 roughly there, up 1 over 1 roughly there. Then I know I go from the origin, I go out 2, up 4. So I could go start at my new starting point up 2, or out 2, up 4, somewhere up there. So draw a little bit nicer of a sketch there. So basically what I'm getting at though is that our g of x is the exact same as our f of x, which is one of the basic functions that we know how to graph right away, just moved up 2. So exact same graph, exact same picture, just up 2. And if it was minus 2, it would be the exact same picture, but down here at 2 units downward. And again, if you're confused a little bit, like, okay, I know it's 2 units upward right here, but I need to plot a few points, you could be like, okay, what about like, let's see what my x value is going to be like when x equals 2, y equals 2 squared plus 2, which is 4 plus 2 is 6. So then I know there's going to be a point at 2, 6. So then you could sketch out a few points, but because you know, okay, I know it's going to be a parabola, I know it's going to be mirrored, I know it's going to be up 2. So if you need to plot a few points to give yourself a little bit better of an idea, that's totally fine. But the main idea is that you're not using just plotting points to graph these functions anymore. You're saying, oh, I recognize that that is a vertical shift up to parabola. So that is vertical shifts. Moving on down to horizontal shifts, this one's a little bit trickier, but again, with more familiarity and practice, it will become very easy right off the top of your head. So let h be a positive number. So then the graph of f of x minus h is the same as f of x moved h units to the right. This can be confusing because it's minus, but it's going to the right. That's kind of non-intuitive, but just something that you need to stick up in the brain and remember. And then g of x equals f of x plus h is the graph of f of x moved k units to the left, okay? So this example is a little bit trickier, but we're graphing f of x equals x squared and g of x equals x minus 2 quantity squared plus 1 on the same set of axes. So I'm gonna go ahead and draw a set of axes for myself. And then I know that my graph of y equals x squared is, sorry, getting my stuff situated here. I know that my graph of y equals x squared is going to be a parabola. Again, so we just did that one in the above example. So let me get a different nice color, throw my pencil around a little bit, and graph y equals x squared. Okay, so I don't need some exact points. That's probably a decent parabola. And then g of x equals x minus 2 quantity squared plus 1. So I know that this means that my graph is going to be, well, from this part, I know it's going to be 2 units to the right. And then from this little part here, I know it's going to be 1 Okay, so if I take my parabola and I move 2 units to the right, and then I move up 1, let me do my final thing in blue, g of x equals x minus 2 quantity squared plus 1, that's going to be my origin, 2 to the right, up 1. So my origin is going to be right here, and then I'm going to have the same kind of parabola. And again, the homework problems are mainly like identifying like, oh, which graph, like they would give you this g of x and then you'd have to pick from a bunch of graphs which one is the correct one. So as long as you understand the transformations, then you're good, and your graphs don't have to be super exact. Like obviously this graph that I just drew is not exact in any way, but I understand that, okay, it's my OG parabola, the yellow guy, moved to the right 2 and up 1. So I understand the transformations that are going on, which would allow me to pick, oh, okay, it's that one, or it's that one. So that is shifting horizontally. And now, last thing is reflecting. Another type of transformation is called a reflection. In this section, we are only studying mirror image reflections, or in other words, when our function is flipped over the x-axis. So, reflection about the x-axis. The graph of g of x is equal to negative f of x is a graph of f of x reflected about the x-axis. So for example, graph f of x equals x squared, another good old parabola. You guys are going to be like so pros at drawing these. And then g of x equals negative x squared on the same set of axes. So again, I'm going to draw my OG parabola in yellow because that just seems to be the theme. So that's this guy. I'm going to color code it, f of x equals x squared. And then in this example, I have exactly what I'm talking about with reflection about the x-axis, right? Because my g of x is equal to negative f of x, negative f of x. So I'm going to go ahead, so I know that my graph is the graph of f of x reflected about the x-axis. So I know which axis is my x-axis. I'm not going to draw it because I don't want to change pen colors and I want to color code this because I'm weird about stuff like that. But anyway, so I know I have f of x graphed, and g of x is going to be the reflection of f of x about the x-axis. So that means I'm just going to flip it over. That's a terrible reflection. But the point is that these two graphs should be the same. So I will label my x-axis. And so we can see how our green graph is the same as our yellow graph, just mirrored over the x-axis. And that is the only type of reflection that we will cover for now. So stay tuned. Yeah, and that's all I got for this video. Enjoy your weekend. Have a lovely, or do something exciting, drink some water, take care of yourself, do some math. Stop screen sharing and stop recording.